The title of this talk is Some Decision Questions Concerning the Time Complexity of Language Acceptors. This is joint work of Oscar Ibarra and Bala Ravi Kumar. The overall outline of the talk is as follows. We'll begin by presenting a motivation for this work, and following this we'll introduce the basic computational models and some definitions that are crucial to understand this work. And following this, we'll present the main results of this paper. Most of the results are either decidability or undecidability results, and in some cases we also present complexity results. For the most part, however, we'll skip the proofs and then we'll present the conclusions. Motivation for this work comes from asking some fundamental question about the time complexity of computational devices. Specifically, if f is the time complexity function for a computational device, we want to know whether an upper bound on f can be decided. Such questions are very basic. In fact, even the Turing machine's halting problem can be viewed as an instance of this type of problem, but it's well known that most of such questions are undecidable. Here we explore the simplest of devices for which such questions are non-trivial and identify cases where the problems are decidable or undecidable. An example of such a problem is as follows. We are given an NFA with epsilon moves, and a question that we want to decide is the following. Can every string W accepted by M can be accepted by a computational sequence in which the number of steps is at most 2 times length of W? Or equivalently, is it the case that for every string there is an accepting computation in which the number of epsilon transitions used is at most the length of the string? We study such questions. In fact, this particular problem is still open. Our problems basically involve determining if the time complexity for all accepted input strings can be upper bounded by given function. Mostly we'll be concerned with non-deterministic devices, and therefore the time complexity here denotes the number of moves in the shortest of all possible accepting computations. For example, one of the questions we would be interested in is whether the time bound is at most the length of the string plus some constant k, where k is independent of the length of W. In other words, we basically want to know for a given device M whether there exists a constant k such that every accepted string can be accepted with at most k epsilon moves. Similarly, we can ask about whether the number of moves is at most k times length of W. We'll also be concerned with questions where the number of moves is exactly k times length of W. Here, k could be either a given constant which is part of the input, or it could be a fixed number, thereby generating a family of problems, one for each value of k.